So in the previous lesson, Marilise spoke to you about this new topic called nature of the roots. And so I just want to spend a little bit of time talking about this thing called delta. And what delta is delta is the thing inside of the quadratic formula. And delta is b squared minus 4ac, where you have a quadratic equation in standard form. So here would be a quadratic equation that I could make up, say 2x squared plus 3x plus 4 is 0. Then we would say a is 2, b is 3, and c is 4. And if I wanted to work out what delta was for this quadratic equation, we would simply go whatever b is squared minus 4 times a times c. Now I'm just going over this because this was in the last lesson. So we get 3 squared minus 4 times 2 times 4. All right, I want you to tell me what is the value of delta for this particular quadratic equation. What is the value of delta? And you can pop it in the chat, or you can let me know over audio. I want to know. Okay, so we get 9 minus, so 4 times 2 is 8, so minus 32, which is minus 23. Now, we haven't had to solve this whole equation. We could have used a formula, but all I want to know now is what are the nature of the roots of this quadratic equation that I just described. So I don't want the answer, but I want to know what are the nature of the roots based on this value of delta. And I've got this table up on the screen that you can use to help you. What does this value of delta tell us about the roots of this equation? Which of the 3 categories am I going to be in? Okay, so Tando, Mbali, lots of students are saying I'm in this category over there, and the roots are non-real because inside that square root bracket, I would have a minus 23. Okay. Now, if delta had ended up being 0, so if delta was a 0, I would have been in this category. And we would say the roots are real, rational, and equal. And if delta had been something like, say, like 17, then we would be in this category over here because it's greater than 0. But I want to know, are the roots rational or are the roots irrational if delta is 17, based on the table that I have here? So if delta is 17, are the roots rational or are the roots irrational? I'd love someone to maybe come online and explain to me why they think it's rational or irrational. We know the roots are real because they're greater than 0, but I'd love a student if they were willing to come on and explain, because this is quite a nice thinking question. Who feels like they can share their thinking? You don't have to be right. I just want to hear how you thought about it. Come on, I know you want to. Yondela or Annie or Klecho, who wants to share with me their thinking? How did you decide what you decided? Tegavatso, let's go to you.
Good afternoon, sir.
Hey. What is your thinking?
We say the roots are irrational because the answer is a decimal number.
Okay. So when you say decimal, I was wondering, you sort of are right. So if you take the square root of 17, it's kind of like a messy decimal, like 4.1, blah, blah, blah. And so you're right. But normally when we look at delta, we look for something particular. And what's special about 17 that tells us it's irrational? I agree with you.
It's not a perfect square number.
There we go. There we go. So it's not a perfect square. Delta is 17, which means it's irrational when we square root it. And so you're absolutely correct. You were looking at the number and seeing it's not a perfect square. Okay, fantastic. Now, if delta was 16, I'm still going to be in this third category, but what are my roots going to be then? They're going to be real and they're going to be different, but they're going to be something else. So if delta was 16, they're going to be real, they're going to be rational, and they're also going to be unequal. Yeah. Annie, I agree with you. Who else agrees with us? Okay, rational. Yes. Okay, so this is the basic idea with nature of the roots. We find what delta is, and depending on the delta value, we can tell stuff about the roots of the equation. Okay, so let us go and practice some of these ideas. I'm going to give you two quadratic equations. I'm going to call them A and B. And I want you to just tell me, I want you to classify the nature of the roots for each of these. I will do the first one, and then you can, actually, you know what, you can do both. I think this is the second lesson, so both, you can do this. You're going to start by deciding what A, B, and C are equal to. And then I want you to decide about the nature of the roots, whether they are equal or unequal, whether they are rational or irrational, and whether they are real or non-real. So those are the three categories that you need to think about when you classify nature of the roots. Okay, everyone, off we go. I want you to try and work out delta and classify for A and do the same for B. And if anybody has questions, I would encourage you to raise your hand and we can chat through it. I know for our new students especially, you may want to ask a question now because you probably didn't get to see the last lesson, and so we can chat further, but for the rest of us, let's try and do it. What do we get for delta for number A, for letter A? Wait, so not put 1, I must put, it should be -2. 1. Yeah, so delta is equal to 0, and when delta is equal to 0, the roots are going to be equal, or they're going to be, let me put it actually like this. They are going to be real, they're going to be rational, and they are going to be equal. Real, rational, and equal. Let's give the second one a go for B. What do we get for this one? Nicely done, Pablo. So what I like to do is I always start by writing down what my A, my B, and my C values are, assuming that we're in standard form. So here, A will be 5, B will be that, and C will be 43. So to classify the nature of the roots without solving the equation, I need to work out what delta is now. Now I want to see what you get for that value, and then I want to see how you classify it. So what's B? B is -3, and it's squared, and A is 5, and C is 43. So the agreement seems to be that delta, that seems pretty big. Let's have a look here if I agree with you guys. So 9 minus 4 times 5 times 43 minus 851. Now, if delta is negative, we just say that the roots are non-real. When we say the roots are non-real, we can stop at that point. Because basically what we have is we have that the square root of a negative number is a non-real number. We don't really deal with it at school, so we can stop with the fact that roots are non-real. Have a quick little vote. Thumbs up if you feel like you're following along reasonably well. Thumbs down if you're feeling a bit unsure of yourself right now. In the chat, if you just give a little vote. Okay, cool. All right, well then let's take it up a little bit if everybody's feeling okay so far. I want to know, let's try and do this one over here. So the roots of the equation, x squared plus 3x equals 4 are what? Are they A, are they B, are they C, or are they D? Now, I'm not going to give anything away. I want you to think about this yourself. But which of the 4 options would you choose? What's your first step going to be? For those who are able, why don't you tell us in the chat, what is your first step? Because I see there's a bit of uncertainty. Some people are saying it's B, some people are saying C, which is nice. It means we have a nice debate. But I want you guys to put, or maybe somebody can come tell me, what's the first step that they did in their approach? Annie, let's go to you. Annie, what did you do first?
Hello, sir.
Hey.
Hello, sir. How are you?
Very good, Annie. Very, very good.
Okay. So first I realized that the equation is not in standard form. So I transposed the 4 to the left, which made it a -4.
Aha, that's important. Yes. Okay. So I think I agree with you. Without doing that, things aren't going to go well for you. And then I assume you found delta. Is that what you?
Yes, I found delta.
Okay, and what did you get for your delta value?
25.
25. Okay, now, what is special about 25?
It's a perfect square.
Okay, that's the important bit. So we know it's real. We know it's rational. And what's the last thing?
And equal.
It's not going to be equal. It's actually going to be
unequal.
The only way it would be equal is if delta was 0. And the reason, let me actually show you this. The quadratic formula has this structure, which is minus b plus minus the square root of delta over 2a. If delta is 0, what happens is that plus or minus 0 is still doesn't make a difference. So that's why the only time the roots are the same is when delta is 0. The moment delta is greater than 0, so in this case it's 25, the roots are going to be unequal because you get minus b plus 5 over whatever 2a is. And you also have a root which is minus b minus 5 over 2a. And so I'm not sure if everybody knows why the roots are different. The moment you have a number in the square root, you have the plus and minus root. And so that's why we're looking to see if delta is greater than 0. Thank you,
Okay.
Annie. That was, what did you choose in the end? I guess we would have chosen C, huh?
Yes, I did choose C.
Perfect. I agree with you.
Thank you.
Is the correct. Thank you for your input, Danny. Okay. Let us question like taking our knowledge is really important and looking at the values. So let's try and do this question 3 over here. But in order to get going, because this trick here, and so I'm hoping somebody can help me figure out how to get started. Has anybody got how we get if it's like here? What do
Go ahead and try out the next one, guys.
I was looking for a tip. That's what before Vodacom got in the way there. How do we get this in standard form? What's going to be the key thing? I'd love to hear from a student in the chat or in terms of the voice if they'd like to. I'll give you a little hint. This 3 over here is bugging me. I'd love to get rid of the 3. What I could do is I could multiply both sides by 3. So yes, Akile agrees with me. Multiply by 3, and Sino the same thing. So if I multiply both sides by 3, I have to basically multiply everything by 3 here and everything by 3 here. Or maybe an easier way to see it is to have like a 3 outside and then a 3 on this side. So I get 6x over here, and on this side, I get x squared plus 9. So what I was doing, I was multiplying through by 3, but I'm still not in standard form. So I'm going to leave it to you to still get the answers. I want to know, do we think the roots are, what the roots are? So Eunice has put a suggestion in about what my standard form would be like that. And then my A is 1. What is delta going to be? So how did we get 9? Yes. Okay, good question. So Ayanda, what we did was when we multiplied 3, if we multiply this 3 by 3 and that one by that, this 3 gets knocked out, but this one over here, 3 times 3 is 9. So that's how we got it there. Does that help? Now with delta, we've got 36 minus 36, which means we have 0. And if delta is 0, we're going to have equal roots and rational and real. So the correct answer is going to be A. A-OK. So I'm just worried I'm going a little bit fast. So can we have another little vote? Thumbs up if you're feeling okay with this. Thumbs down if you're feeling a bit overwhelmed. Be honest, we don't mind. I just want to make sure I'm keeping myself in the right ballpark here. Okay, cool. Well, let's do one more before the break around nature of the roots. Can you find me the nature of the roots for this equation without solving the equation? Give you a little tip. It's this X over here that's causing us problems. I see some unhappy faces. So I was thinking we multiply both sides by X. And the reason we do that is so that we can get rid of that fraction X. So we have to multiply this, we multiply that, we also have to multiply this. So this is going to give us 1, and this is going to give us 2x squared, and this is going to give us 5x. And then if we bring this to this side, that should be our standard form, and then delta should be minus 5 squared times 1. So delta should be 25 minus 8, which is 17, which is delta is going to be real. So the roots are going to be real, they're going to be unequal, and they're going to be irrational, which is B. Awesome, awesome, awesome. We are doing nicely, everyone. Should we squeeze in one more before the... No, actually, let's take a break. We've earned a break. So let me go to this happy chap. And can I have everyone's cameras on? And can I have you standing on your feet? Because that would be awesome.
Please turn on your cameras, guys. Let's see your lovely faces.
Yes, don't let me have all the fun, everyone. Because we know that sitting for too long is bad for you. So stand on up and just loosen those arms, swing them a little bit from side to side, and just feel like you're loosening up. Because you've been sitting and thinking for half an hour, so everything's quite tight. Oh, that feels lovely. And now, because my shoulders are a little bit tense, I'm going to roll them lightly. So I'm just going to roll them back. 5, 1, 2, 4, 5. And then I'm going to roll 5 forward. 1, 2, 3, 4, 5. Then I'm going to take this one across and just stretch it out. Yeah. 1, 2, 3, 4, 5. Other one. Oh, I'm enjoying this. 3, 4, 5.
Feel good.
Yeah. Then what I want to do, I think I did this last week and it's such a good exercise. It's called pen flipping. So grab like a pen or something with a bit of weight that you can toss in the air. Make sure there's no one too close to you and you're not going to knock over a coffee cup or something. And the idea is that you spin it so that it spins once in the air and you catch it on the same side. So one rotation and you catch it. It's very easy to make it spin too much. So let's see who's the best pen flipper here. Ooh. So there we go. Keep practicing. 1. There we go. I got it.
A couple of drops there.
It's a
Things
fine
are getting
balance
out of
between power and
hand.
control. This is like the Jedi, like test, like it's not too much, not too little, just enough. Okay. Oh, too much. And then just switch across to your non-dominant hand, just to see how different that feels to you when you're flipping it. Actually, I'm quite good with my left hand. I think my right hand kind of gives it too much power. Yeah. I'm a natural with my left hand. Wow. Okay, cool. So whenever you need a break at school, tell your teachers about pen flipping. It's a really good exercise. Okay, now the last thing today, before our little maths puzzle, is we're going to do something that a student suggested in the last lesson. I think it was Emmanuel, and he said to try air skipping. So instead of doing jumping jacks, we're going to do air skipping. So the way it works is you pretend you have a rope in your hands, and then you skip 1, 2, like that. Okay, and we're going to do it we'll do 20 air skips. So we're starting 3, 2, 1, and go. 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And that is a nice.
So glad you didn't say burpees of the air. I'm so scared.
Yeah, burpees is a bit much, but that's a nice high heart rate activity, and it was a good suggestion. And so if anybody has a high heart rate activity that you think would be good, let us know and we'll do it in a future lesson. Okay, this next part is the Maths 24 game. And what you need to try and do is make 24 using the 4 numbers on a card. And so you try and choose, you have to use these 4 numbers to make 24. And so the red one is sort of the easier one. The blue one is a bit harder. See if you can make 24 using these cards. And it's just a good mental maths exercise for you.
Who will be first?
Okay, so we have to use all 4 numbers. So we've got, so 5 times 5. So that is Regile. So 5 times 5 minus 4 minus 3. So let's just check. 5, 5, 4 minus 3. And this is 25, and this is 1, so that's 24. So Regile, I completely agree. And Kumo agrees. And Chuma has a different way. Oh, 5 times 3 plus 5 plus 4. This feels familiar. I wonder if we've done this recently. So that's great, Chuma. And so the red one has been conquered. What about the blue one? I see Leah has a suggestion for the blue one. So 4 times 4 plus 8 times 1. So that would be 16 plus 8 is 24. So that would be 24. And times 1 is 24. So Leah has definitely got a blue one sorted. Anybody else got the blue one? Or any other suggestions for the blue one? Okay. Well, I think that we have then done well as a group. We've conquered both of these Maths 24s. And I'm just curious to know, guys, do you feel like the brain break gives you, like, we're about to start the second half of the lesson. Do you feel like you benefited, like your concentration? And again, you can be brutally honest. How did the brain break? Did you find it helpful? I'm always curious. I'm always to see how students are experiencing these things. So yeah, pop it in the chat if you've got a moment. Okay, then I want you to classify the nature of the roots for this question B, the one in yellow. So I'll do my best and I'll speak to Cyril. So when so what I want is everybody to have a go at this one. I want you to try and classify the nature of the roots for this one in yellow. And I will take questions from the class and we can give each other hints in the chat if we like. But let's see how will we do this one? Who would like to give us a hint about our first step? So someone who's willing to share their thinking. It looks a bit more cluttered than before if I look at it. Okay, so we could factorize Sino, but I'm also wondering, okay, let's go to Annie. Annie, what do you think? What would you do first?
Hello, sir.
Hey.
So I would multiply into the brackets on the left.
Totally. And I see Mbali and Danya agree. So I think what we need to do is multiply these brackets out and then go from there. So I'll give a bit more time. Thanks for that. So what are we getting for our delta value? That's what I want to know. I agree. Delta is 64. So what are the nature? The roots are definitely real. And because 64 is a perfect square, they are going to be rational. And because they're not zero, they are going to be unequal. So the roots are real, rational, and unequal. Very, very nicely done. I want everyone to try the pink one now. Can you do question C? Can you classify the nature of the roots of the pink one without solving the equation? Nicely, Nezel. That's good. Unequal, real, rational. Perfect. Let's do the pink one now. I'll write it down here so you can all see it. So we're trying to understand, how do I classify the nature of the roots for this one? It feels like this is what gets in the way. What should I do? Who would like to share some of their thinking? Who has a tip for me? A top tip? Because this looks quite interesting. It's a bit like intimidating. Tato. Tato said multiply with the denominator. So it's divided on this side. If I bring it to this side, it's going to be times. So I could get 4x squared plus 2x plus 1 equals 2 times whatever that was. Yes, I like that. That looks good. And now I suppose we have to try and get it into standard form and then find what delta is as well. So I want to know what delta is from the class here. Okay, so I want to know what are the nature of the roots and what is delta? So pop your delta value in the chat and then pop what you think how you would classify your roots. So b squared is minus 6 squared, so that should give me 36. And then this should be minus 4 times 4, so minus 16. So I get a delta value of 20. So what are the roots of my equation going to be? My rather tricky looking equation up here, I can classify its roots without solving the equation. So roots are real. They are irrational because delta is not a perfect square, and they are unequal. So real, irrational, and unequal. Yeah. So Lele agrees as well. Yeah, I like what I'm seeing, and you're definitely handling more difficult types of questions. And so because you're looking quite comfortable, I'm going to move on to the next type of question, because we've got about 5 to 8 minutes or so left. I want to know, though, before we try and do this question, what is different about this question 9? So just take 30 seconds to read it, and I'd love some comments from the class about what they think is different about this question. So I'm waiting for your lovely thinking. What's different? For which values of k are the roots x squared plus 2x plus k real? So the constant is a letter. Yes, it's all about this k over here. Now, if we do know something about real roots though, so what does delta have to be for the roots to be real? Well, delta has to be greater than or equal to 0. If delta is less than 0, if it's negative, it's non-real. We can't have that. All we need to make sure is that delta is greater than or equal to 0. So what I'm going to suggest to you is think about, work out what A is, work out what B is, and for your C value, you're just going to say that's equal to K. And then I'd like you to try and use that if you can to try and guess what the answer for, will it be A, B, C, or D? This is a bit of a tougher one, but it's good to extend you a little bit. So if A is 1 and B is 2 and C is K, normally what we do in this section is we try and find what delta is. I'd love you to have a go at this. So far, I have C and D as part of the options. Who else? Lock your vote in there. For which values of K are the roots real? Now, in almost every question we've done so far, we found delta. So I'm just going to find delta on faith a little bit. And it looks to me like delta should be 4 minus 4K. So if delta is 4 minus 4K, we know that 4 minus 4K should be greater than or equal to 0. Now, we did inequalities last week. And so when we did that, we said that they behave a lot like equations, except for a couple of things. So what I'm going to do now is I'm going to bring that across to the other side. So 4 is greater than or equal to 4K. And then if I divide both sides by 4, I should have 1. So K should be less than or equal to 1. Aha. Let's just see that. Let's see if everyone agrees with me. Take a moment. Oh, I think I've caught quite a few of you here because a lot of people are saying C. I disagree. I think the answer is A. So let's just repeat and check that everyone is on the same team here. We're happy that A is 1, B is 2, and C is K. We work out delta. It's B squared minus 4AC, and we get 4 minus 4K. Now, in order for delta to be real, in order for the roots to be real, delta must be greater than or equal to 0. So that's this bit at the top here. But now when I want to solve for K, I'm moving the 4K to the other side. Aha, but Clermont, we didn't divide here. So all I did was I moved this to the other side. I didn't divide, I just added. So there was no dividing. If, for some of you, if you did this, if you moved the 4 to the other side and you had this, right? If you had that, then you could divide by minus 4. And you're quite correct. You would switch it around then. So you have K is greater than or equal to 1. Ooh, wait, what's going on here? Minus 4. And that would be, oh, but then that must switch around. Sorry, then this should be switched around, yeah. So then the moment you divide it by minus 4, it should be going that way. Why am I not getting the same answer? No, I'm getting the same answer. Yeah. Sorry, having a moment there. Look at how the K is getting the smaller side in this one, and it's getting the smaller side in this one. It's the same answer. The hungry mouth is going to the 1. So the answer actually should be, I'm being silly, is that, am I being silly? No, it's A. It's definitely A. Okay, I'll go through this again because I think I've confused myself and you for a little bit. So let's do this one more time from the top. Apologies for the uncertainty. Give me a thumbs up if you understand how I got delta. Give me a thumbs up if you understand how I got delta. I'm humbled. So am I sometimes. Okay, so most of us, not all of us, but a lot of us understand how I got delta. I was just using these values over here. So now, if the roots are real, delta is greater than or equal to 0. So give me a thumbs up if you understand this bit here. So when the roots are real, delta must be greater than or equal to 0. So like if we look back in today, let's have a quick look. When delta was 17, can you see that the roots were real because it's greater than 0? But when we went back to the very beginning, let's say 25, they were rational. It has to be, delta has to be greater than or equal to 0. Okay, now don't worry, some of you can rewatch this afterwards, but let's just go through it now. So we get 4 minus 4k is greater than or equal to 0. So now I need to solve this inequality. I have to solve it. And what I'm saying is the easiest way is just to take this to the other side, in which case we have this situation. Now when I moved it across, I didn't divide by a negative there. So all I'm going to do is I'm going to divide by 4. And then I get 1 is greater than or equal to, and then this is going to be k. This cancels out. Notice how the hungry mouth is going to the 1. The bigger one is going to the 1. So that's why I was saying over here in A, the hungry mouth is going to the 1, and it's also the greater than, or, well, it's this one over here. Okay, that was a tricky one to end with, but I hope that it's a little bit easier now that I show you this last part here. Okay. For those who were dividing by the negative, for those who wanted to move the 4 across, you still get the same answer. So I'll do it for you now. If I do it like this, if I bring this 4 across instead, I get this. And now I have to divide by negative 4. Now, this is where in an inequality, if you're dividing by a negative, you have to switch the signs around. So on this side, we have a k. The hungry mouth has to switch to the other side, and minus 4 over minus 4 is 1. And that's the same answer again, because the hungry mouth is going to the 1. Okay. Cool. Lebo, if I could ask you to please put the link to the quiz for this week in the chat. If that last one really has you in a muddle, don't worry. In fact, the quiz is completely based on the ones we did earlier, but it's just good to have a little look at something a little more complicated every now and again. Okay, and I do hope that you enjoyed the lesson. Rewatch this last bit if you feel very confused. And I see Lebo has put the link to the chat. And to our new students, I do hope that you enjoyed the environment. Remember, on Monday, we are starting a new unit. And so today is really just about getting familiar with how Watobe works. But yeah, we do hope that you enjoyed the experience. Are there any final questions, everyone? Any comments or questions? Well, then, I'm going to say, Vivian, I see you have your hand up. Let's unmute Vivian.
Hello, sir.
Hey.
I just wanted to say, we missed you on Monday a lot.
Oh, thank you.
Also,
yeah.
sorry, sir. But that K over there, can't we say there's a -1? Or is it because it's the C value you can't do that?
Yeah, because so that K has a plus in front. And so because it's a C value, it's just going to be plus K, essentially. You can't make it a negative. So,
Okay.
so that one, I mean, yeah, no, you can't. You have to just say whatever thing is in that place, it's a plus C by default. No.
Okay. Okay. Thank you so much, sir.
Cool. Have a good rest of the week, man.